Mathematics, Pew Mathematics Paper 1, Wednesday, 6 June 2018. Answer all questions and ensure that your answers to parts of questions are clearly labeled. You should show sufficient working to make your methods clear. Answers without working may not gain full credit. Given that theta is small and is measured in radians, use the small angle approximations to find an approximate value of 1 minus cos 4 theta divided by 2 theta sine 3 theta. When theta is small and measured in radians, sine theta is approximately theta, tan theta is approximately theta, and cos theta is approximately 1 minus theta squared over 2. So we're going to use this one and this one. So that means cos 4 theta is approximately 1 minus, instead of theta, we replace it with 4 theta. So we replace 4 theta there instead of theta. So it becomes 1 minus 4 theta all squared over 2. And sine 3 theta, we replace sine theta, replace theta with 3 theta. So sine 3 theta will becomes approximately 3 theta. So the numerator now would be 1 minus bracket 1 minus 4 theta all squared over 2. And the denominator would have 2 theta times 3 theta, because sine 3 theta is now 3 theta. Now we can remove the brackets for the numerator. Minus 1 times 1, it gives you minus 1. And minus 1 times 1, 16 theta squared over 2. 16 divided by 2 will give you 8. So it will be 8 theta squared. So this numerator will become 1 minus 1 plus 8 theta squared. 2 theta times 3 theta. 2 times 3 is 6. And theta times theta is theta squared. So it's 6 theta squared in the denominator. 1 minus 1 is 0. So it's 8 theta squared divided by 6 theta squared. The theta squared will cancel from the top and bottom. 8 divided by 6 is 4 over 3. So when theta is small and measured in radians, 1 minus cos 4 theta over 2 theta sine 3 theta is equals to 4 divided by 3. Question number 2. A curve C has equation. Find dy over dx. Before you differentiate it, we are going to write square root of x as x to the half. So when you differentiate x squared, you get 2x. When you differentiate minus 2x, you get 2. And when you differentiate x to the power half, you multiply by the half times 24 times x to the half minus 1, which will be minus a half. And half of 24 is 12. So you have 2x minus 2 minus 12x to the minus a half. That's dy over dx. D squared y over dx squared, you differentiate the second time. And when you differentiate, you multiply by the power and subtract 1 from the power. Two things. Multiply by the power, subtract 1 from the power. Do not confuse with integration. So differentiating 2x will just give you 2. Differentiating 2 will give you 0. And differentiating 12x to the minus a half, the minus a half will come in front. So you multiply by the power, which is minus a half, and then you subtract 1 from the power. So it would be the minus and the minus would make a plus. Minus a half minus 1 is minus 3 over 2. So your answer is 2 plus 6x to the minus 3 over 2. Part B, verify that C has a stationary point when x equals to 4. At stationary point, dy over dx is equals to 0. So that shows there is a stationary point. So you can sub in 4 in dy over dx. You got dy over dx from the top there. So you sub in 4 for x. You get 2 times 4 minus 2 minus 12 bracket 4 to the power minus a half. And you put it all in your calculator and press execute. So you do it at once, not bits of, don't do 2 times 4 and things like that. And you will get 0. So you do not have to solve it, just sub in and verify. And that tells you it has a stationary point. Part C says determine the nature of the stationary point. So nature means you want to find out if it's a minimum point, it's a maximum point. So you use the second differential. You differentiate the second time, which you've done over at the top. There is 2 plus 6x to the minus 3 over 2. And you substitute x equals to 4. So 2 plus 6 times 4 to the minus 3 over 2 gives you 2.75. And that 2.75 is positive. So when d squared y over dx squared is positive, when d squared y over dx squared is positive, that means it's greater than 0. That means it's a minimum point. And another way you can do it is you just look right at the top right. You can plot the graph using your graphics calculator. Put that function in the curve, plot it, and you will see the minimum point at minus 4, at 4 minus 40. So your graph, the calculator will check it for you by showing you the picture, and you can see a minimum point there to confirm it. So that's question 2, and the answers to part A and part B. That shows the answers to part C, question 2, and also some other explanations for 2A, B, and C. And this page shows the formula that were used for doing question 2. So that's how you differentiate, multiply by the power, and subtract 1 from the power. So this is just the differentiation formula. And this is the one that was used to determine if it's a local minimum point. You differentiate the second time, put in the value, and if it's bigger than 0. So you need to learn all of this when you do questions with differentiation. Question number 3. Figure 1 shows a sector AOB of a circle with center O and radius r centimeters. Given that the perimeter of the sector is 4 times the length of the arc AB, find the exact value of r. So what the question is saying is that the perimeter, imagine you start from O, you walk to A, and then go around the arc to B and back to O. So O to A down the arc to B, and then back to O. That gives you the perimeter. But they say it is 4 times the arc. That is the arc there. So that perimeter is 4 times the distance for that arc. And we're going to form that equation and solve it. So to find the arc length L of a sector of a circle, use the formula L is equals to r theta. So we need to memorize that, where r is the radius of the circle and theta is the angle in radians contained by the sector. And to find the area of a circle, use the formula area is half r squared theta. We want to find that yellow area, where r is the radius of the circle and theta is the angle in radians. Make sure the angle is in radians. Don't forget, the angle has to be in radians. And then that's formula for segment. We're going to use this formula. So the area, half r squared theta in radians. So they've told us the area is 11 and half times r squared times theta. That gives us equation 1. Perimeter, you add the first radius plus the second radius plus the arc length. That gives you the perimeter. Watch that. First radius, second radius plus the arc length. And r plus r, it gives you 2r. And the arc length is r theta. So that means 2r plus r theta is equals to 4 times r. Where did the 4 come from? Because it tells us in the question is 4 times bigger than the arc length, 4 times. Now we can get r theta plus to the other side, it becomes minus. So 4 r theta minus r theta is like 4 apples minus 1 apple. So it'll be 3 r theta. So 2r equals to 3 r theta. And we can have 2 times 11 over r squared. So implies theta is 22 over r squared. From this equation 1, take the 2 there. 2 times 11 is 22. Divided by r squared, it gives you theta. So we make r the subject from equation 1 and sub it into 2. So we know theta is 22 over r squared. We put that into equation 2. So that means 2r is equals to 3r times 22 over r squared. One of the r's will cancel. 3 times 22 is 66. So 2r equals to 66 over r. Take this r to the left. 2 times r is 2r squared. Divide by 2, you get 33, and r squared is square root of 33. So we leave it as square root of 33 because it says they want the exact value. So the exact value means leave it as third form, not decimal. Question number 4. The curve with equation y equals to 2 ln 8 minus x meets the line y equals to x at a point x equals to alpha. Show that 3 is less than alpha less than 4. So what we do for part A, that's the equation. So we substitute 3, f of 3. So wherever we see x, we put 3. And that will give us 0.22. And the important thing there is positive. And then after that, we substitute 4. And that will give us minus 1.23. And it is negative. So it has gone from a positive, across the x-axis, and goes to a negative. So the change of sign from positive to negative means the function is continuous. The change of sign and the fact that the function is continuous in the interval 3 from 3 to 4, that means there's a root in the middle. That's what you conclude. Make sure you write that sentence. There's a change of sign and the function is continuous in that interval. So there's a root. If you don't write that, you won't get the full mark. For part B, a student uses the iteration formula. It says determine whether or not the iteration formula can be used to find an approximation. When it can find an approximation, it keeps moving closer to one answer. You can see if you start at 4, you go to the curve, back to y equals to x, back to the curve, back to y equals to x, back to the curve. You can see it is spiraling inwards and getting closer and closer to the answer. So you conclude can be used to as iterations converge to the root. Converge to the root. Spirals inwards or gets closer to the root or it converges. That's what you will say. The iteration is converging to the root, and you can see it goes to the graph, back to the y equals to x line, back to the curve, back to y equals to x line, back to the curve. Is getting closer and closer to the root, which is there in the middle. So that's question 4. And that's a graph showing the question 4 in detail, which you can see each spiral. So it goes to the curve, to this line y equals to x, back to the curve, back to the line y equals to x. And that's the curve. And it's getting closer and closer to the root, spiraling inwards because the cobweb spirals inwards. Question number 5. Given that y is equals to that, show that dy over dx equals to a over 1 plus sine 2 theta, where a is a rational constant to be found. What we want to do, we want to differentiate. And the numerator will call it u, and the denominator will call it v. So we're going to use the quotient rule, and I've written it here: v du minus u dv over v squared. So the numerator is u. Differentiate the numerator, du over the theta is 3 cos theta. The denominator is v equals to 2 sine theta cos theta. And differentiate the denominator, you get 2 cos theta minus 2 sine theta. Put them together in this quotient rule formula. It's going to be long. You need a lot of space, and write neatly so you can see any mistake. So we first of all put v, and then we put du over dx, minus we put u, and then we put dv over dx, and then underneath we put v squared. That means multiply that by itself. Now you remove the bracket, multiply that together, and multiply that together, you get this. The next part, remove the bracket, multiply this 2, multiply this 2. That gives you this 2. And then the denominator, you have to multiply out the double bracket. 2 sine theta times 2 sine theta, it gives you 4 sine squared theta. 2 sine theta times 2 cos theta, it gives you 4 cos theta sine theta. 2 cos theta times 2 sine theta gives you 4 sine theta cos theta. And 2 cos theta times 2 cos theta, 4 cos squared theta. Now, you look at the numerator, which you just multiply out, and you look at the denominator. So you would end up with 6 cos squared theta plus sine squared theta, because this would cancel with this, it will become 0. This and this will cancel each other and become 0. So you got 6 outside of bracket, cos squared theta, sine squared theta. You go to the denominator, 4 will come out of the bracket, and you have sine squared theta, cos squared theta. And add these two together, you get 4 plus 4 will give you 8 cos theta sine theta. So cos squared theta plus sine squared theta is 1. It's identical to 1. And this one is identical to 1. So you end up with 6 over 4 plus 8 cos theta sine theta. And this is where you have to make some arrange to get it to what they want you to. 6 is the same as 2 times 3. And then you factorize the denominator. 4 is the same as 2 times 2. 8 is the same as 2 times 4. So you factorize 2 bracket 2 plus 4 cos theta sine theta. So these 2 will cancel. So you end up with 3 divided by 2 plus 4 cos theta sine theta. Now, there's a technique where you divide the top, each of them you divide by 2, you divide by 2, you divide by 2. So dividing all of them by 2, you haven't changed anything. It is a fair method. So you got 3 over 2 at the top. 2 divided by 2 is 1. And this one gives you 2 cos theta sine theta. And you remember from double angle formula, 2 sine theta cos theta is sine 2 theta, which you put there. And that is what they wanted you to find. So that's question 5. And that's another explanation for question 5 in summary. For question number 6, the circle has center A with coordinate 7, 5. For part A, show that an equation of the line PA is 2y plus x equals to 17. So these are some of the key things about circles that we can use. A tangent to a circle is perpendicular to the radius. And the equation of a circle with center 0, 0 is x squared plus y squared. And the equation of the circle with center AB and radius r is x minus a squared. That's the formula there. And if the gradient of AB is m, then the gradient of its perpendicular bisector is minus 1 over m. So we might use some of these ideas. So it's very important to remember them. So we have the line is y equals to 2x plus 1. So we want the gradient of PA. the line is perpendicular to the radius. That's the line there. It's perpendicular to the radius. So to get the gradient of the radius is minus 1 over the gradient of the line. So we deduce that it is minus a half, minus 1 over 2. And we use this formula for equation of a line. Y minus y1 equals to m bracket x minus x1. It passes through 7, 5. So y is 5, x is 7, and the gradient is minus a half. So we know y is 5, x is 7, and the gradient is minus a half. You put that, you rearrange it, you will get 2y plus x equals to 17. QED, quod erat demonstratum, which means as required to show. And the center of the circle is 7, 5. PA is the radius, that's PA there, is the radius of the circle. And we know the line is y equals to 2x plus 1. So for part B, it says find an equation for C. So we have 2y plus x equals to 17, equation 2. So we substitute for y, we replace y with 2x plus 1. And we get this equation where we solve it, and we will get x to be 3. And when we substitute x is 3, we'll get y to be 7. So P is 3, 7, and A is 7, 5. Now we want to find the distance between P and A. So we use that distance formula. So it's 3 minus 7 all squared plus 7 minus 5 all squared, and square root of that. So that gives us square root of 20, which means the radius is r squared is 20. So equation of the circle is the x minus 7 all squared plus y minus 5 squared is equals to r squared. But r squared is square root of 20 squared, which is 20. For part C, we can do it in one of these ways. We have the line meets the circle. So we replace y with 2x plus k. It's a long process, replacing y with 2x plus k. So where we see y, where y was, we put 2x plus k. So we expand x minus 7 squared, and that gives us x squared minus 14x plus 49. And we expand this 2x plus k minus 5 squared. And when we write it twice like that, and you expand it, you will get all of that. And then we start to collect like terms and put them together, and you would eventually get this expression. So A is this, B is that, and C is this one. So because the line touches the circle, which is a tangent or one repeated root, you use b squared minus 4ac equals to 0. So you know your b is 4k minus 34. So you do b squared, you multiply it twice, minus 4 times a is 5 times c is that expression there. It's long and tedious, but you take your time, you multiply it out, collect like terms, you get a to minus, you get this quadratic. And you solve that quadratic, use your calculator. So that gives you k to be plus 1 and k to be minus 19. So y equals to 2x minus 19. You can draw, and then you can use your calculator to check it. Or you can attempt to find where y equals to 2x plus k meets c using OA is equals to p plus a. So substitute 11.3 in y equals to 2x plus k to find k. So that means you substitute 3 for y and 11 for x, and you solve it, you will get k to be minus 19. I think this is quicker and easier. So that's question 6a. And these are the formulae and ideas that we use for it. One way to do question 6c. Question 6c continues. And the easier way to do question 6c. Question number 7. Given that k is an element of z plus, show that integral of that is independent of k, and part B is also to show. So what we want to do, we want to use this formula I've put at the top there. Integral of k, f dash of x over f of x dx is, you use ln f of x. So using that formula, we can have adjust the integral to look like that formula. So I'll show you how we do that. So 3 times something will give you 2. What do you multiply by 3? What do you multiply by 3 to get 2? You will make it 2 over 3. So because why do we do that? We want to have 2 at the top. When you differentiate the bottom, you get 3. But do we have 3 in the numerator? No. What we have is 2. So how do we change that 3 to 2? We multiply by 2 over 3, and that will give you the 2. So that's where we have 2 over 3 outside to adjust the integral. And now the top will change to 3. The denominator will stay the same. Now when you integrate, you use this formula. That just gives you ln 3x minus k. And we're integrating from 3 to the k and k. Substitute 3 to 3k for x. Wherever I see x, you substitute 3k. And we will simplify that. And then we also substitute for k. We substitute x for k. So that gives you 3 times 3 is 9 minus 1 is 8. So ln 8k. And when you substitute k, 3k minus k would just be 3k minus 1k would be 2k. And when you subtract logs, you divide them. So 8k divided by 2, it gives you, the k will cross out. 8 divided by 2 gives you 4. So it's 2 over 3 ln 4. And you notice there is no k in it. So that means it's independent of k. Independent means there is no k in the final answer. For part B, if we use u is equals to 2x minus k, so we substitute whatever is in the bracket there. So we find du over dx. When you differentiate 2x, you get 2. K is just a number. You differentiate k, you get 0. Now we want to make the x the subject because we want to replace the x. Remember, we're going to replace the x. So we make the x the subject. So take 2 to the left. It becomes the x is du over 2. So we will replace the x with du over 2. Remember that. Now we need to change the limits. The limits go from x equals to 2k. So we take x equals to 2k. So what would u be? It will be 2 times 2k minus k. It gives you 3k. When x equals to k, we want to get u. So we put x, k is there. 2 times k is 2k minus k. It gives you k. So we are integrating now from k to 3k. We have changed the limits. And we've replaced dx with du over 2. We replace 2x minus k with u. And then the square stays the same, and the 2 at the top stays the same. That's what we're doing. Replace 2x minus k with u. The square stays the same. The 2 in the numerator stays the same. And we replace the x with du over 2, which we found from there. And then we change the limit from k to 3k using that expression to change the limit. Now, when you cross out the 2, you take u squared to the top, it becomes u to the minus 2. When you integrate, you add 1 to the power and divide by the new power. Minus 2 plus 1 will give you u to the minus 1 divided by minus 1. So minus 1 over u. We substitute 3k and we also substitute k. So the minus 1 over 3k minus 1 over k. This minus and minus becomes a plus. So minus 1 over 3k plus 1 over k. It gives you 2 over 3k. And 2 over 3 is just like a number. times 1 over k. So that means it's proportional to 1 over k because 2 over 3 is just a number. So therefore, it's proportional to 1 over k. So that's question 7a. Question 7b. This shows question 7b written neatly. And also the final part of question 7b written neatly. Question number 8. The depth of water d meters in a harbor on a particular day is modeled by the formula. Part A. Find the depth of the water in the harbor when the boat enters the harbor. So T is equals to 6.5. So we substitute T is equals to 6.5. And you put that in your calculator. It will give you 4.48 meters. And you would use your calculator in degrees because that's in degrees. For part B, we have 3.8 is equals to 5 plus 2 sine 30t. So we divide by 2 and find the inverse sine of that. That will give us 30t to be minus 36.8698. So 360 minus that, it gives us 30t. So 323.13 will give us 30t. And t will be 10.77, which is 10:46 a.m. or roughly 10:47 a.m. if you want to use that. So if we have, for example, 12 midnight, and we have 1, 2, and we get up to 10 in the morning, that gives us 10 hours. And then 10:47 minutes. So 10:47 and 10:77. So we will have 13 minutes less of 11 a.m. That's question 8. And the final part of question 8. Question number 9. Figure 4 shows a sketch of the curve with equation. Show that dy over dx is equals to y minus x over 3y minus x. When we differentiate x squared, we get 2x. Power to the front and minus 1 from the power. So it's 2x. When we want to differentiate 2xy, this is where most students have problems. There's two things there, x and y, and we are differentiating with respect to x. So we can call all of these 2x as u and call the y as v, and we use product rule. So that would be y times du over dx, which is y times 2 plus 2x times differentiating y with respect to x gives you dy over dx. Differentiating 3y squared is another problem with students. Just differentiate it like with respect to x. 3 times 2 is 6, 6y, and then add a dy over dx. And when you differentiate 50, you get a 0. Now you remove the bracket to get this expression. And then you want to put the dy over dx together. So the 6y dy over dx, so dy over dx is common. It can come out of the bracket. And then the 6y minus 2x. And then you take minus 2y to the right, it becomes plus 2y. And you take 2x, it becomes minus 2x. Now, take all of this 6y minus 2y to the right. It becomes divide by 6y minus 2y. And you factorize 6y minus 2y to 2 brackets 3y minus 2. The 2 will cancel. You're left with y minus x over 3y minus x. For part B, at the point P and Q, dy over dx is infinite. So infinite change in y for 0 change in x. So for a little bit of change in x, the change in y is infinite. So dy over dx is y minus x over 3y minus x. So the denominator would be equals to 0. So we want 3y minus x to be equal to 0. So 3y is equals to x. You take x to the right hand side, and y is x over 3. That's your equation 1. And this is equation 2. So we want to substitute 1 into 2, equation 1 into 2, and find where the line meets the curve. So we replace y with x over 3. So we get this expression. And we can multiply all of them by 9, so that we get rid of the 3 and 9. So you times this by 9, times by 9, times by 9, times by 9. So you would end up with this expression, and you would minus 6x squared plus 3x squared will give you minus 6x squared is equals to 50 times 9. So x squared would be 75, and x will be square root of 75, which is plus or minus 5 root 3. Now y is x over 3. So at p, you have minus 5 root 3 and minus 5 root 3 over 3 for y. So that's your x and that's your y. And for part C, you solve y equals to x and y is equals to this simultaneously and choose positive solution. So you are solving the straight line y equals to x, which goes through the origin, and this simultaneously, and then you choose the positive answer. That's how you do part C. So that's question 9, part A, question 9, part A and part B, and part C for question 9. Question number 10. The height above the ground, h meters, of a passenger on a roller coaster can be modeled by the differential equation. So part A says show that h is 5e to the 0.1 sine 0.25t. So we are given the h over dt, the h. What we want to do, we want to integrate. So the opposite of differentiation is integration. So we want to integrate the right hand side, which is integrating that function. So we have, when you integrate 1 over h, you get ln h. And you have 1 over 40, which you can take out of the integral sign. And then you differentiate cos 0.25t. Differentiate 0.25t, that gives you 0.25. So you divide by 0.25. And then the integral of cos is sine. So 1 over 0.25 sine 0.25t plus c. Don't forget the constant of integration. We know h is 5 and t is 0. So we substitute h is 5 and t to be 0. And we want to find c, the constant of integration. And that gives us c to be ln 5. So we write the whole expression with ln 5 for c. Now ln h means log to the base e of h, or log of h to the base e, natural logs. So that will give us h is equals to e to the power 0.1 sine of 0.25t plus ln 5. And we can have e to this power and also e to the power of ln 5. But e to the ln 5 is just 5. You can put that in your calculator and you'll get 5. The ln to the power ln and e will cancel, just get 5. And the 5 will come in front. We'll always put the numbers in front. So h is 5 e to the 0.1 sine 0.25t. For part B, maximum height is when the sine of 0.25t is equals to 1. So when all of that, the power is equals to 1, it's 1 there for sine of that. So it's e to the 0.1 times 1. Replace that with 1. So put that in your calculator, you get 5.53 meters. And for C, we sketch there a sine graph. Sine of 0.25t equals to 1. So when is it 1? When sine of 90. Sine 90 is 1. Next time it's 1. Sine 450 is also 1. So we can have 0.25 t equals to 450. And we can multiply by pi over 180 to change to radian. So that gives you 5 over 2 pi. So you want to change degrees to radian, you multiply by pi over 180. So 0.25 t is equal to 5 over 2 pi. So you divide by, take the 0.25 to the right, you divide by 0.25, and t is equal to 10 pi. 10 times pi is 31.4 seconds. That's question 10A. Question 10B and C.